So, building agentic AI applications using CrewAI. These are the table of contents. Now, LLM models itself do not have access to external data. Neither they have access to tools to connect to external databases and systems. And these multi-step workflows and autonomous workflows are not possible by using only LLM based applications. So LLM applications use a control flow by building chains, that is pre-post LLM calls. Now these chains are reliable and deterministic. However, in a real world scenario, if the decisions that which step comes after which step, so the invocation of steps, if that could be picked up by LLM itself, then the entire flow of the application could become autonomous. So if the LLM has that capability of deciding the next steps of the application, then we can think of developing an agentic system. So agentic AI motivation, the features like enhanced knowledge integration. So since we can connect to different real-time data from various sources in form of databases, APIs, so it has an enhanced knowledge integration, action execution capability. So it can bridge this gap by incorporating functionality to execute code also, interact with other systems and perform complex actions directly, which is not possible in an LLM based application. It can handle complex tasks such as accessing external databases, performing these control flows, sequential operations, interacting with APIs, and then memory. So agents can store relevant information and recall it as needed. Now, agent design patterns. So it's essential to understand how each pattern empowers the LLM to behave more autonomously and effectively. So first is self-evaluation, then tool integration, strategic thinking, and collaboration. So self-evaluation or the reflection pattern is the ability of the LLM itself to improve its answer and evaluate and refine its own output. Tool use pattern. So with agents, we can significantly broaden an LLM's capability by allowing it to interact with external tools and resources. Then planning. So the planning part or the decision making part, by breaking down large complicated tasks into smaller, more manageable components, that can be done by agentic systems. So it equips an agent with the ability to react to requests and strategically structure steps needed to achieve a goal. And then multi-agent patterns. So instead of assigning a single agent with multiple tasks, we could have multiple agents handle subtasks of a particular larger problem and communicate within themselves and collaborate to achieve a combined goal of a problem. So the components of these agents, right? So it has a memory system where we have short-term memory, long-term memory. So in short-term memory, we could have a conversational agent and we could keep the conversation and feed it as a context whenever required. In long-term memory, we can connect it to some vector database, some external knowledge. In agents, we could also connect them to some tools. It could be a code interpreter, a search tool, calculator, API, any external API we can connect as a tool to the agent. It has this capability of self reflection, of evaluating its own output. And then sub goal decomposition. So the key features of an agentic framework is like there are some boilerplate pre-built components and abstractions so that these developers could quickly set up agents and workflows. Integration with tools and environments, communication between agents, memory management, monitoring and debugging. So when we deploy these agents, we need to have a built-in monitoring capability and observability so that we can track the performance degradation or model drift over time, and human in the loop. So these are the popular agentic AI frameworks. We have CrewAI, LangGraph, Semantic Kernel, AutoGen by Microsoft, Llama agents. Hugging Face is providing the small agents, Phi data. So these are some of the popular agentic AI frameworks which helps us to use an LLM and automate the workflow. Here we will be discussing on LLM AI agents with CrewAI framework. So it's a cutting edge framework for orchestrating autonomous AI agents. So it enables you to create AI teams where each agent has specific role, tools and goals, and working together to accomplish complex tasks. So think of it as assembling your dream team. Each member brings unique skills and expertise, right? So this is the structure. So first we will have a set of agents. They might be individually connected to a set of tools, and in the process we will bind how these agents will execute. Each of these agents will have specialized tasks assigned to them, and overall we can um, combine them inside a crew. So these agents internally can delegate their work or reach out to one another and communicate within themselves and ask questions and do the work. The processes define how the agents will work together, so the interaction sequence between them, and the tasks can override agent tool with specific ones. So crew is the top level organization, agents are the specialized team members, process is the workflow management system, and tasks are the individual assignments. So we will discuss each of them individually, like agents, right? So we have to define these specific parameters when we are defining agents in CrewAI. So role of the agent, goal. Goal is like a very simplified objective of what the agent is trying to achieve, and then a backstory will have a contextual information and a narrative that can affect the agent's behavior. And then we can plug in tools, so the agents can be equipped with tools to extend their capabilities such as web search engines or data analysis tools. And then configuration, so agents are configured using YAML files, allowing for modular and flexible setups, right? So this is an example. We have defined a research agent. The role is a research analyst. The goal is find and summarize information about specific topics. And in the backstory, we are telling that you are an experienced researcher with attention to detail, and the tools are the SERPer dev tool. So this is nothing but a search tool. For that individual agent, for each of those agents we have to define tasks parameter in CrewAI. and this task parameter will have these particular arguments that we need to define. So the description of the task, here we have to define the detailed description of the task, and the agent that will perform the task will be mentioned here along with the expected output. And you here also you can define the tools that the agent will utilize. And async execution, so it indicates whether each of the tasks performed by the agent can be executed asynchronously. So if they are not interdependent between one another, we can set this as true, right? Then the crew object, so to bring the tasks and the agents together, we are defining the crew object. So we are passing the agents and the tasks. So here you can see I've defined the crew object and the agents that are going to be performing the task along with the tasks, and then you have to kick off your crew. And here we are going to get this output, right? So if crew object dot json dict, then we can print the json output, or you can also print out the output using your pydantic library. So this is nothing but to get the structured output out of the crew. And then the processes in CrewAI, so how the agents will orchestrate the execution of tasks, that we can define inside this process field when we are defining the crew. So we have agents, tasks and process. This process could be sequential, hierarchical and consensual, right? So planned. And then memory management in CrewAI, so uh, this framework provides different sets of memories, so short term, long term, entity and contextual memory. So you have defined your crew, and simply if you turn this memory equal to true, then the memory will be set by default. And you can also have custom memory where you can keep all these parameters, right? So recency weight, semantic weight, importance weight, recency, half cycle, life days. So using this by importing this memory class, you can also define a custom memory, and that you can plug in while you are defining your crew. So this is also possible. This is how you can set up memory in your agentic framework. Whereas you can also define your memory by importing this memory class, and you can also mention that this memory will be active within the scope of this particular agent. So that is also possible, but there you have to define it within the agent itself for defining it in a private scope, right? And then we have flows in CrewAI. Now this gives more reliability and more flexibility, because with only agents and that process field, right? So the execution of different components of your application can become restricted, but flows gives you the flexibility that you can inject some part of normal code, and then you can uh, keep the agentic system code, right? So as you can see here, you have some normal code, and then you can have some part of your application which is doing some llm based processing, or some agentic system code is there. So there you can parallelly keep these together, and then you can have another normal code which will have some logs, and then you can combine all of these together, and then you can simultaneously kick off your crew. So that kind of flexibility where you can have different parts of your code injected within llm based application. So for that flexibility, flows are very important in CrewAI. So it allows you to create structured event driven workflows. And for a simple example, you have to import this flow. Here we are defining these outputs, right? So simple function we have. So we have to start when we are importing this flow class. We have to use this decorator at the rate start, and then in the next function, when we are defining the next function, we have to like define this at the rate listen decorator along with importing the first function, right? So and then whenever you finally kick off the crew, the first function will be printed and then the second function output will be printed, right? Okay, now memory management with Crew, like every flow has built-in memory, right? Now using these parameters like self dot remember, self dot recall, self dot extract underscore memories. So these are the specific methods that we can use inside any flow method to access memory, right? So as you could see here, we are using this self dot remember and then this findings. So this particular sentence will be saved in the memory, and we can also define the scope here. And similarly, in the listen decorator, we are using this self dot recall method, right? Okay, then we have something like execution hooks. So this is also important. um, so like before you are kicking off your crew or your agent, you want to have some kind of input filters, right? For that you can use the hooks, and also after you have generated the output. So for these kind of uh, pre and post processing of input and output, we could have something like an execution hooks. So you could define that within your task, right? So when you're defining the task of a particular agent, you could have a pre hook and a post hook parameter, and this pre hook could be some function that you could define, and post hook also could be some function that you could define separately, but that will be triggered when you are defining the task parameter for a particular agent. And then we will discuss on tools in CrewAI. So the framework is more powerful because it gives access to more than 200 plus tools built in the framework itself, right? So tools is nothing but when you send your data out to and connect to some external resources and pull the data from the source. So tools provide capabilities to agents. Access to too many tools can degrade performance. Common tools include files and folder, web scraping and browsing, database connections, code execution, and so on. Now considerations for tool calling in CrewAI. So definitely we want to have some error handling in place, right? So when the tool does not execute, what will happen? So the fallback mechanism of a particular tool that needs to be present. Then caching, so cross agent caching to optimize performance and reduce redundant operations. Asynchronous support, so handles both synchronous and asynchronous tools, enabling non-blocking operations, right? So we can have all these tools executing parallelly and enabling these non-blocking operations. So the simple components of tools could be the name, description, and the inputs, and custom code could be the authentication, API calling, service connection. Okay, so the tools in AI, you could again define it within a decorator tool, and then you could have any function as tool which you can connect to your agent, right, using this tools parameter. So for ensuring the reliability that a tool functions correctly, right, so it must have some kind of a fallback or some kind of rate limits that you need to define. So multiple times you're trying to connect to the tool and it is returning some error. Now it should not go into a infinite loops. There must be some maximum usage limit, and there must be some tool repository which could be shared across multiple agents and tasks. And for that we have uh, a new protocol, MCP, developed by Anthropic. So everyone exposes the tools differently. So MCP is basically when different frameworks try to define the tools, how they access the tools and the arguments differently. That's where MCP came, so that there is a common agreement on how agents get access to tools, resources and prompts. So here we will have some kind of a client server architecture in between to unify the communication between an agent and a tool. So adopting MCP, this is an open protocol for tools, resources and prompts. So JSON RPC 2.0 under the hood, it's a client server architecture, right? So we have like tools, prompts and resources, which are the components of MCP, and the transport protocol we could use is STDIO or SSE or streamable HTTP. Now CrewAI and MCP, so agents both inside the crews and outside of crews can use these MCP servers. They allow them to filter and aggregate tools. Crew themselves can also become MCP servers, allowing them to be used by other agents. So here you could import this MCP server adapter. You could like give link of the application which is running behind your MCP server, and then you could give it as a tool to your agent, right? So this MCP will also be given as a tool, connected as a tool to your agent. These are some safeguards for MCP server, right?